Module number 13. Loops. Loop is a control flow statement that executes same piece of code or same set of statements 0 or more times. Types of loop structures in C program are while loop, for loop, do while loop. Let's discuss each of them one by one. While loop or while statement. The generic form of while statement is while, condition, statements and next statements. Whenever control comes to this while statement, then the time first it executes condition. If this condition is true, the following statements or the loop statements will be executed. Otherwise, that control will jump to next statements. Whenever this condition is true, all statements in the while block will be executed. After execution of last statement in the while loop, the control will transfer back to while statement. Again here it will check the condition. If this condition is true, again it will execute this statement. Whenever it executes last statement of the while loop, the control will transfer back to while statement. This process will be continued until the condition is false. If this condition is false, the control will jump to next statements. Let's consider one example on while statement. Here 1 is assigned to x and 0 is assigned to sum. Here the condition is x less than or equals to 10. One is assigned to x. The value of x is 1 and the value of sum is 0. Whenever the control reaches while statement, first it checks the condition. Here the condition is x less than or equals to 10. It will check 1 less than or equals to 10. This condition is true. So it evaluates the statements in the while loop. The first statement in the while loop is sum plus equals to x. This means this is the compound assignment statement. Sum equals to we can write this expression as sum equals to sum plus x. Here the value of sum is 0 and the value of x is 1. After evaluating this expression, the value of sum is 1. So the value of sum is 1. After evaluating this expression, the control will pass to next statement. Here the statement is x plus plus. This means x equals to x plus 1. X equals to x plus 1. Whenever control comes here, it will evaluate this expression, that is x equals to x plus 1. The value of x is 1. And after evaluating the expression, the value of x is 2. So it will store 2 in x. X plus plus 1 is last statement of while loop. So after evaluating this last expression, the control will transfer back to while statement. After evaluating the first iteration, the value of the x is 2 and the value of sum is 1. So here condition is, again it check the condition. Here condition is 2 less than or equals to 10. 2 less than or equals to 10. This condition is true. So the statements in the while loop is executed. They are sum equals to sum plus x. That is, here sum value is 1 and the x value is 2. The total expression value is 3. This 3 is assigned to sum. This 3 is assigned to sum. After that, the next statement is x plus plus. Here x value is 2. After executing this expression, the value of x is 3. This is the last statement of the while loop. After executing this statement, the control will transfer to while statement. Here again, it checks the condition. This process will be continued up to x greater than 10. If x is greater than 10, the condition will be false and the loop will be terminated. The control will jump to the next statement of the while loop, that is printf %d sum. After evaluating this expression, you will get the value of sum is 55. This code evaluates sum of first 10 integers. They are 1 plus 2 plus 3 so on to 10. The value of 1 plus 2 plus 3 up to 10, that equals to 55. It evaluates this value. Let's consider some more examples on condition using with relationship operators. Here some examples are, let us assume I equals to 10 and j equals to 15, b equals to 3 and c equals to 2. The most important thing in loops are checking the condition. Here the condition is I less than or equals to 10. So the I value is 10. 10 less than or equals to 10. This condition is true. Always you have to check while this condition. If this condition is 0 value or non-zero value. 0 value means false and non-zero value means true. 0 value means false and non-zero value means true. This condition is true or false. Here this condition is true, so it means it is non-zero value. So the statements in the while loop will be executed. The condition of second statement is I less than or equals to 10 and logical end j less than or equals to 15. Whenever an expression has more than one operator, then the time we will check the precedency of that operator. Whenever an expression has more than one operator, then the time we will go for precedency. We will check the precedency of that operators. The condition of second statement is I less than or equals to 10, logical end with j less than or equals to 15. Here we have three operators. They are relationship operator, logical operator and relationship operator. Whenever an expression has more than one operator, then we will go for precedency levels of that operators. Here the precedency of less than or equals to is more than logical and operator. So first it will perform I less than 10. Next it will perform j less than or equals to 15. First it will perform I less than or equals to 10. Next it will perform j less than or equals to 15. After that the logical AND operator will be performed with getting values. I less than or equals to 10, this is true, and j less than or equals to 15, this is also true. Why? Because I value is 10 and j value is 15. So both are true. true logical and with true. That is true. So this condition also true. The condition in third statement is j greater than 10, logical and with b less than 15 and c less than 10. The condition is j greater than 10 and b less than 15 and c less than 20. Here we have greater than operator, logical and operator, parenthesis operator, and less than operator, and parallel operator, and one more operator is less than operator. Here we have more than one operator. Then the time we will check. First we will check precedency levels of that operator. The precedency of parenthesis is high. So first it will evaluate this parenthesis expression. In this parenthesis we have logical OR operator and relationship operator. This relationship operator has more precedency than logical OR operator. So b less than 15 will be evaluated first, and next it evaluates c less than 20. That is 3 less than 15. 3 less than 15 is true, and c less than 20. C less than 20 also true. After that it evaluates the parallel operator, logical operator, that is true logical OR with true. That is the value of that expression is true. So the total value of this parenthesis expression is true, and j greater than 10. Here the value is 15 greater than 10. So after evaluating this expression, the value is true. This condition is j greater than 10. This condition is true. So now true, logical and with true. That is true. The condition of third statement is, the condition of third while is true. Let's assume in place of this logical OR we have left shift operator. Then the time how this condition will be executed. As usually, first it evaluates this parenthesis expression. The parenthesis expression is b less than 15, b less than 15, left shift operator, and c less than 20. Here we have more than one operator, that is relationship operator, less than operator, and left shift operator. Whenever we have more than one operator, we will go for precedency levels of these operators. The precedency level of left shift operator is more than less than operator. So first it will check 15 left shift operators C. 15 can be represented as 4 zeros and 4 ones. Here the value of C is 2. So it shifts 2 specified number of bits towards left. Then the time we will lost 2 bits at leftmost position. That is, we will lost these two position bits. This many bits are paired with zeros rightmost end. That is 00, 4 ones and 00. Here the value is 60. Here the value is 60. Whenever you are performing this is, you will get 60 here. That is, after evaluating this expression, you will get b less than 60 and less than 20. Here we have two operators. In this time, associativity plays the role. Here less than operators are associativity. Left to right associativity. Then the time it will check first this expression. After that it will check this expression. So that is b less than 60. The value of b is 3. So 3 is less than 60. Then the time the value will become true, that is 1. Let's examine this example. Whenever you are performing left shift operator, then the time you will get set of ones and zeros. The value of set of ones and zeros is 60. But here you are performing less than operator. Then the time, that means you are performing relationship operator. Then the time you will get the value is true or false. Here the value is true. So true will be represented as 1. So b less than 60, the value is 1. 1 less than 20. This expression also true. So the value is 1. So the value of this parenthesis 1 is 1 or true. The value of j greater than 10 is true. So true and true. That is true. So the total condition will be true. The generic form of first statement is for initialization expression, condition expression and increment decrement expression. After that statement and next statements. Whenever the control reaches first statement, first it evaluates initialization expression. After that it checks the condition. If this condition is false, then the time the control will jump to next statements. Otherwise, that means the condition is true, it will evaluate all statements in the for loop. Whenever the control reaches last statement in the for loop, after evaluating that last statement, the control will pass it to or the control will transfer it to first statement. Here first it will, whenever the control back to the first statement, first it evaluates increment. First it evaluates increment expression. After evaluating this increment expression, again it will check condition expression. If this condition is true, again the loop will be evaluated. Whenever it reaches last statement of the loop, again the control will pass to first statement. Whenever it reaches the first statement, after completion of iteration, first it evaluates the increment or decrement expression. After that it will check this condition. This process will be continued up to until this condition is fails. If this condition is fails, the control will jump to or the control will pass to next statements. Once again consider this first statement. Whenever the control reach here, first evaluated expression is initialize 1. This is the first part to evaluate. After evaluating this expression, the control will check the condition. The control will pass it to condition statement. Here it will check the test condition. This is the second stage. After checking this condition, it will execute the statements in the for loop. That is body of the for loop. This is the third part to evaluate. Whenever it reaches last statement in the for loop, the control, after evaluating this statement, the control will pass it to first statement. The control will transfer back to first statement. Whenever the control is transferred to for loop, then the time it evaluates increment or decrement expression. This is the fourth one. After evaluating this one, it will check this condition. And again, if this condition is true, it evaluates all statements in the for loop. This process can be repeated until this condition is fail. If this condition fail, the control will jump to next statements, which are followed by the for loop. Let's consider this code once again. Whenever control reaches the first statement, first it initializes the expression. After that, the control check the condition. If this condition is true, it will go to third part, that is, it will execute body of the for loop. Otherwise, it will goes to next statements which are following the for loop. Suppose condition is true, it evaluates all the statements in the for loop. Whenever it evaluates last statement in the for loop, the control will transfer back to first statement. Once it comes to here, once it completes the iteration, it will check the increment or decrement expression. After checking this expression, the control will goes to condition part. Here it will check the condition. If this condition is failed, the control will transfer to next statements. Otherwise, it will repeatedly execute this block until this condition is fails. Let's consider one example on first statement. Whenever control reaches here, first it evaluates initialization expression. The initialization expression here is I equals to 0. It will assign 0 to I. And next, it will evaluate condition. It will test this condition. Here the condition is I less than or equals to 128. First, it will check the initialization part. Next, it will check condition part. If this condition is true, it will go for loop body. After evaluating this block, the control will transfer to or return to first statement. Here, it will check this I++. The fourth executed one is I++. If condition fails, the control will jump to fifth statement. The control will reach to out of the for loop. If condition fails, the control will comes out of the for loop. So first I equals to 0, that is I equals to 0. After that, the second one is it will check this condition. The condition is I less than 128. That is 0 less than 128. Then the time it will execute all the statements. It will execute the statements in the for loop. That is, we have only one statement. Printf %d equals to %d I and I. Here the value of this character is null. This null is assigned to 0. The output after first iteration is null equals to 0. At second iteration, after executing this one, this is the last statement in this for loop. So the control will goes to here and it will check this increment operation. I++, that is I equals to 1. Now it will perform test condition, that is 1 less than or equals to 28. This condition is true. Again it will execute the for loop block, that is %d equals to %d I comma I. That is, the output after second iteration is 1 equals to SOH. This means starting of heading. The output after third iteration is 2 equals to STX, starting of text. Like that, after 65 iterations, the output will become 65 equals to capital A. And 66 equals to capital B. Like that, 90 equals to Z. The output will, like that, the output will comes out. The next loop statement is do while loop statement. The generic form of do while statement is do statements while condition and colon. Whenever control reaches here, first it evaluates statements. After that, it will check the condition. If this condition is true, the control will pass it to do statement. Otherwise, if this condition is false, it will continue with next statements of the while loop. Consider one example on do while statement. Here 10 is assigned to I. Do. Printf, I am in do while loop. I equals to %d, comma I. I minus minus. First it evaluates the statements. So the statements is, the output of the program is, I am in do while and I equals to 10. After that it will perform I minus minus. Means I equals to 9. Here first the 10 will be assigned to I and it will execute the statements in the do loop. That is, I am in do while loop. I equals to 10. After this statement, I minus minus, that is I equals to I minus 1, that is 9. After evaluating this second statement, the control will goes to while statement and there it will check the condition. 9 greater than 0 or not. 9 greater than 0. This condition is true. Again the control will pass to do statement. There it will perform the statements in the do loop. Again it will perform I am in do while loop. I equals to 9. The next statement is I minus minus, that is 8. Likewise, it repeatedly performs until the condition is false. The condition false whenever I less than or equals to 0. Whenever I is equals to 0, the condition will be false. The output will become like I am in do while loop, I is equals to 10, likewise I equals to 1. The next topic is break and continue. In some situations we may want to skip the code or we may want to terminate the loop. Then the time we use break and continue statements. This break statement causes termination of the loop and continue statement causes it will skip the code following the continue statement and starts with next iteration. That means whenever you will get continue statement in the loop, then the time the following code of the or the following statements of the continue will be skipped and it will starts with next iteration. Whenever you will get break statement in your loops, then the time it simply terminates the loop and it will pass the control to next statements of the loop. Consider one example on break statement and continue statement. In first example, we are using break statement in the for loop. For x equals to 0, x is less than 10,000, x plus plus. If x square modulus operator 5 equals to 1, then break. Otherwise, do something. That means whenever the if condition is true, it simply terminates the block and it will goes to next statement of the for loop. Loop is terminated whenever x square modulus by 5 equals to 1. If this condition is true, the loop will be terminated. Consider the second example. If this condition is true, it will continue with next iteration. That means the following code will be skipped. That means printf %d, all those things will be skipped and it will continue with next iteration. Suppose at first iteration the value of x will be 1. At first iteration the value of x will be 1. Then the time the condition is 1 modulus 5 equals to 1. That is true. So the control will goes to continue statement. Whenever it sees the continue statement, it simply skip the following code and it will starts with next iteration. That is, the next iteration is 2. Here 2 into 2. Here the value is 4 modulo 5. The value is 4. So the condition is false. Then the time it will evaluate the printf statement. Whenever this condition is true, it simply skips the following code and starts with next iteration. Consider one example on continue statement. Here I is declared as integer type variable. Whenever the control reaches this statement, first it initialize the control variable I, that is I equals to 0. After that it will check the condition I less than 100. This condition is true, so it will evaluate for loop statements. That is, the for loop statements are if I modulus 2 equals to 0. Whenever this condition is true, it simply continues. That means the following statements under this continue statement are skipped. That means whenever I is equals to 0, this condition is true. So the following statements are skipped and it will continue with next iteration. That is I equals to 1. 1 modulus of 2. This condition is false. So it will goes to else block and it will print the value of I. The output is, first it will print 1. After that it will goes to first statement and increment the value of I. That is 2. 2 modulo of 2. That is 0. This condition is true. Then the time it will perform continue operation. That is, it will skip all the statements under this continue statement and it will start with next iteration. The next iteration is I++. The next iteration is 3. Again it will check 3 modulo of 2. This condition is fail. Then the time it will printf %d I, that is 3. Likewise it will print 1, 3, 5 up to 99. This code will execute odd numbers in between 0 to 100. They are 1, 3, 5 up to 99.